Good afternoon to Miss Ain, and my name is Farhan Rarni, metric number 0108687, and I'm standing here beside with my Sendent Intercool CPW 0511, and it is a showcase refrigerator. This unit is located at BRC College in Unimas, which has an ambient temperature of 23.4 Celsius. And as you can see, the distance between the refrigerator and the wall is 30 cm, and the distance of this showcase refrigerator and other refrigerator is 4 cm. This refrigerator, it's used R134A refrigerant, and its rate of power 438.4 watt. This is model CPW0511. It was manufactured in June 2011 in Thailand. It is substantial pieces of equipment weighed in at 114 kilograms. Looking at the power requirement, this unit operates on a 220 to 240 volt single phase system at a frequency of 50 Hz. Its running current is 2.37 ampere, which bring the total voltage to approximately 438.4 watts. The cooling and refrigeration system, it uses R134A refrigerants with a total charge amount of 454 grams. The system is designed for specific pressure range. The low side pressure is set at 20 psig, while the high side pressure reaches 200 psig. For efficiency and temperature retention, the cabinet used cyclopentane insulation, which is a high-performance thermal barrier. We measured the physical dimension of the refrigerator that's shown in the photo, recording a height of 0.6 meter or 60 cm, width of 0.3 meter or 30 centimeter, and the length of the refrigerator is 0.24 meter, which is 24 centimeter. I use this value to calculate the total surface area for the leak analysis. To get an accurate internal temperature, I use the thermodynamics technique, submerging a digital thermometer probe into a cup of water inside the fridge to stabilize the readings. I then record the temperature every 30 minutes over a 3-hour period to monitor how the units maintain its cooling efficiency over time. This is the data that I recorded, observing how the water cooled from an initial 87.8 degrees Celsius to a final reading of 11.8 Celsius. We also track the compressor activity to determine its duty cycles, noting that it remained active for most of the session to maintain a steady internal air temperature of approximately 11.2 degrees Celsius. In this calculation, we determine the rate of heat transfer Q in through a material by applying Fourier law of heat conduction. After converting the boundary temperature to Kelvin, we find a temperature gradient between 296.55 Kelvin and 284.37 Kelvin. When substituting this value into the formula Q in equal to Ka delta T over delta X, the result confirms a heat transfer rate of 3.032 watts, representing the energy flow across the specified barrier. This is the observation table. I monitored the compressor over 180 minutes, recording that it spent a total of 96 minutes running and the remaining time idle. This represents the percentage of time the compressor is active by dividing the 96 minutes of running time by the 180 minutes total, we find a duty cycle of 53.3%. The actual work in to find the real power consumption, we multiply the rated power of 438.4 watt by the duty cycle 0.53, resulting in an actual work value of 232.35 watt. This thermodynamic analysis calculates the system's performance by link-in, heat conduction, compressor activity, and efficiency law. By applying the first law of thermodynamics, we calculate the total heat rejection as 235.38 watt and the actual COP of 0.013. Finally, the second law analysis revealed a system efficiency of only 0.06% when compared to the theoretical Carnot limit, which is the 23.35, with an entropy generation of 0.7831 watt over Kelvin, indicating the level of irreversibility within the cycle. So, the conclusion is the system is losing the most energy at the compressor due to mechanical wear and high thermal gradient. And to improve this, I recommend a better ventilation and replacing the door gasket to reduce the work required by the compressor. That's all from me. Thank you.